Well, now let's take a look at the speeds of two vehicles. And we've still got our basic formulas up here, up at the top. R equals the rate of speed, D equals distance, T equals time. And here we have a problem where Mr. Anders and Miss Rich each drove home from a business meeting. Now we're told here that Mr. Anders is traveling east at 100 kilometers per hour, and Miss Rich traveled west at 80 kilometers per hour. So Mr. Anders is headed off in this direction, and Miss Rich is headed off in this direction, opposite directions. And then we're asking how many hours were they apart? Were they 100 miles apart? How long did it take for them to reach 100 miles away from each other, with this, let's say, as their starting point? Now, this is a place where having a table may actually come in handy, and I've inserted one right here. So here we got Mr. Anders, and I'm going to label this A. And he's traveling at 100 kilometers per hour. Now, we don't know exactly how much time he went, but what we're eventually going to be asked to solve is this distance. And so I'm looking now at this formula right here. Rate times time equals distance. And so I've got a rate, and I don't know the time. That's actually what I'm being asked to solve. But I've got a rate here. Rate times time is 100 t, and my distance, plugging it into this formula, is for Mr. Anders is distance equals 100, the rate, times the time. Now here's Miss Rich. I'm going to label her B because I don't want to do R, because we're dealing with R in our actual formula. Now Miss Anders, we have this table here. She's traveling at 80 kilometers per hour, and according to the distance formula, I would have 80 times t, so D equals 80 plus t. Now one key thing is asking how far they're apart. They're moving in different directions. They're moving this way, apart. So there's my basic data, but let's go here and solve this problem. So what I do know is that they are going to be 100 miles apart, and it wants to know how much time. So now I'm going to go back here and I'm going to plug into this formula right here. So I want to find for time. I know my distance is 100 miles apart. So there's my D. Now my rate is, I've got Mr. Anders traveling at 100 kilometers per hour going east, and I've got Miss Rich traveling west at 80 miles per hour. So I've got two rates, one distance. So if I'm going to solve this, I've got my setup. I've got it into this formula, what I'm trying to find for time. And so I'm going to have 100 over 180. Okay, so when I determine what 100 is over 80, whether I do it in a decimal or a fraction, well, it kind of depends on how it's going to ask the question as to what I want to use. But it's asking for an hour. I'm just going to leave it in a fraction for right now. And when I reduce that down, or if I divide 100 by 80, I get 5/9. So in 5/9 of an hour, Mr. Anders and Miss Rich will be 100 miles apart. Now, the fact that it's asking me about the apart, and we'll see this play out in the next problem, is why I'm adding these two rates together. So in 5/9 of an hour, they will be 100 miles apart. Now let's take a look at one more. Speed of two vehicles. And so in this problem, we got a cyclist begins traveling at 18 miles per hour. And at the same starting point, an inline skater following the cyclist's path begins traveling at 6 miles per hour. After how much time will they be 24 hours apart? And so again, I make a little table. So I got a guy on a bicycle, and he's traveling 18 miles an hour, and I got a guy as a skater going 6 miles an hour. Now the difference is, though, these guys, they're headed in the same direction. So it's not like they were moving in opposite directions, not even like they're trying to meet each other, as what we will often see in many of these types of problems. But these two individuals are headed in the same direction, and it's really asking us, when will they be 24 miles apart? So when this one's here and this one's here, it's 24 miles. Now, if you look at that and you think about that, rather than adding the 18T and the 6T together like we did in the previous problem, and like we'll do in many of these type problems, I'm actually going to subtract them because I'm trying to figure out when are they going to be apart? What's the difference between the two? So let's go ahead and get our setup. So we've got D. When we know what D is going to be, let me put this in a different color, D is going to be 24 miles. That's how far we want to know when they're apart. And we've got one skater going at 18T, 18 miles an hour over a given period of time. And I'm going to then subtract this 6T because, again, I'm looking for this point right here. I'm looking for the difference in the distance that they had traveled. So to solve this, now I go 24 equals, well, 18 minus 6 is 12T. I divide 24 by 12. And in 2 hours, the cyclist traveling at 18 miles per hour and the inline skater traveling at 6 miles an hour, in 2 hours, they will be 24 miles apart. A little different twist on this particular problem, solving the speed of two vehicles. And of course, I want to give you one to solve for yourself. And so here's the problem. Two trains are leaving Raleigh at the same time. One traveled north and one traveled south. First train is traveling north at 50 miles per hour, and the second train is traveling south at 60 miles per hour. So we got one headed up in this direction, going north. We got another one coming down here south. They're moving away from each other. And so it says, in how many hours will they be 275 miles apart? So we got a distance of 275 miles. We got a rate of one train at 50 miles per hour and a rate of a second train at 60 miles per hour. And we're asked to solve for time. Now, I'll give you a hint. The fact that they are moving apart from each other and they left at the same time means that we're going to be adding our rate versus time plus rate versus time equals our total distance. So we got the two vehicles. There's your hint. Now, if you're watching this online, of course, I want you to comment or reply with an answer or even a question if you don't know what to do. And if we're in class, I may be calling on you. Let me give you a few moments to write this problem down, and good luck. Okay, well, hopefully you've had time to write it down. You may have already solved it, as smart as you are.